The 1980s, a decade of neon lights, synth music, and revolutionary technology. But while most people remember the Walkman and the personal computer, something equally remarkable was happening in the fields of Europe. European engineers were designing farm machines so advanced, so innovative, that they would set the standard for modern agriculture for decades to come. Today we're counting down 10 European farm machines from the 1980s that were genuinely years ahead of their time. These weren't just incremental improvements, these were game changers that revolutionized how we grow our food. Some of these innovations are still in use today, and some concepts were so advanced that the industry is only now catching up. So grab your overalls, fire up that tractor, and let's dive into agricultural history. Number 10. Claas Dominator 108 SL Maxi Combine Harvester, West Germany, 1985. Coming in at number 10 is the Claas Dominator 108 SL Maxi, and this beast redefined what a combine harvester could be. Released in 1985 by the German manufacturer Claas, the Dominator 108 wasn't just big, it was smart. This machine introduced revolutionary cooling systems that prevented overheating during those long harvest days, something that plagued earlier models. But here's where it gets interesting. The Dominator featured an advanced grain monitoring system that gave farmers real-time feedback on crop quality and yield. Think about that for a moment. In 1985, most farmers were still estimating their yields by eye. The Dominator 108 was giving them digital readouts. It featured a cabin that was pressurized and air-conditioned, which might sound basic now, but back then, that was luxury meeting practicality, keeping dust out and operators comfortable during 14-hour days. The hydrostatic drive system was another innovation that made this machine incredibly smooth to operate, especially on hillsides. Many modern combines still use variations of the technology Claas pioneered with this model. The Dominator 108 could harvest up to 10 hectares per hour in optimal conditions, which was absolutely mind-blowing for the mid-80s. Number 9. Rauch Axera EMC Spreader, West Germany, 19. At number 9, Rauch Axera EMC Spreader, West Germany, 1980. We have a machine that might not look exciting, but revolutionized precision agriculture. The Rauch Axera EMC Spreader. Rauch, a German company, introduced the Axera with electronic mass control in 1989, right at the tail end of our decade. But this was agricultural technology that was genuinely ahead of its time. The EMC system used early computer technology to precisely control fertilizer distribution based on field conditions, speed, and application rates. Before this, fertilizer spreading was an art form mixed with guesswork. Farmers would estimate, adjust manually, and hope for the best. Over-application wasted money and harmed the environment. Under-application meant poor yields. The Axera changed everything. The machine featured electric actuators controlled by an onboard computer that adjusted spreading patterns in real time. It could maintain consistent application rates even as the tractor changed speed or encountered slopes. The spreader also had boundary spreading functions, reducing waste at field edges by up to 90%. This technology laid the groundwork for modern precision agriculture. Today's GPS-guided variable rate application systems, they owe their existence to pioneers like the Axera EMC. Rauch was thinking about sustainable, efficient farming before it became the buzzword it is today. Number 8. Kverneland Plow PX100. Norway, 9. Number 8 takes us to Norway and a plow that changed how we think about tillage, the Kverneland PX100. Now you might be thinking, it's just a plow, how revolutionary could it be? But the PX100 introduced a fully hydraulic on-headland turning system that was genuinely innovative. Before this, turning a plow at the end of a field required the operator to stop, manually adjust settings, turn around, and reset everything. It was time-consuming and physically demanding. The PX100 automated this entire process. With the push of a button, hydraulics would adjust the plow bodies, prepare for the turn, and reset for the next pass. This saved hours of work per day and reduced operator fatigue dramatically. But Kverneland didn't stop there. The PX100 featured an automatic width adjustment system that could adapt to different soil conditions on the fly. Heavy clay, the plow would adjust. Sandy loam, different setting, automatically applied. The frame was built using finite element analysis, which was cutting-edge engineering in 1987, making it incredibly strong while minimizing weight. The PX100's design principles influenced virtually every modern reversible plow. That automatic headland management you see on contemporary plows, thank the PX100 for pioneering it. Number 7. Amazon UX Trailed Sprayer, West Germany, 1984. At lucky number 7, we have the Amazon UX Trailed Sprayer, which brought precision to crop protection like never before. Introduced in 1984, the UX series featured Amazon's revolutionary UX control system, which was one of the first electronic spray control systems available to farmers. This system maintained consistent application rates regardless of driving speed, something that sounds basic now but was groundbreaking in the mid-80s. The UX also introduced automatic boom height control using ultrasonic sensors. These sensors measured the distance to the crop canopy and adjusted boom height automatically to maintain optimal spacing. This reduced drift, improved coverage, and minimized waste. In windy conditions or on uneven terrain, this technology was a game changer. The sprayer featured individual nozzle control, allowing operators to turn off specific sections to avoid overlapping and double application. The onboard computer calculated area covered and volume remaining, taking the guesswork out of mixing and application. Environmental regulations were tightening in the 1980s, and the UX helped farmers comply while actually reducing costs. Less chemical waste meant lower input costs and reduced environmental impact. The UX demonstrated that precision and profitability could go hand in hand, a lesson that shaped modern sprayer design. Number 6. Grimme DL1700 Potato Harvester, West Germany, 1988. Halfway through our list at number 6 is the Grimme DL1700, a potato harvester that set new standards for gentle crop handling. Grimme, the German potato machinery specialist, released the DL1700 in 1988 with a focus on preserving crop quality. Potato harvesting had always been tough on the crop. Bruising and damage during harvest reduced storage life and market value. The DL1700 tackled this problem head-on. The machine featured Grimme's patented soft-touch separation system, using rubber-coated rollers and carefully designed drop heights to minimize damage. The separation bed used a combination of agitation and rolling motions that was far gentler than traditional systems. Damage rates dropped by up to 40% compared to conventional harvesters, but the innovation didn't stop at gentle handling. The DL1700 introduced advanced stone separation that could distinguish between potatoes and rocks with remarkable accuracy. The optical sorting system, primitive by today's standards but revolutionary for 1988, could identify and remove clods and debris before they reached the storage bunker. The harvester also featured an electronically controlled digging depth system that adapted to field conditions, preventing digging too deep and bringing up excess soil or too shallow and missing potatoes. This adaptive technology increased harvest efficiency by up to 20%. Number 5. Fendt Farmer 300 series with Vario transmission, West Germany, 1989. Number 5 is where things get really interesting. The Fendt Farmer 300 series, which introduced technology that would revolutionize tractor transmissions forever. In 1989, Fendt was working on what would become the Vario transmission. But the Farmer 300 series introduced the electronic control systems and hydraulic innovations that made continuously variable transmissions practical for agricultural use. While the full Vario wouldn't arrive until the mid-90s, the 300 series laid the crucial groundwork. These tractors featured Fendt's advanced turboshift transmission with electronic control, offering seamless shifting and optimal engine loading. The system used electronic sensors to monitor engine load, ground speed, and implement requirements, then automatically selected the ideal gear ratio. This kept the engine in its most efficient power band, reducing fuel consumption by up to 15%. The 300 series also introduced sophisticated hydraulic systems with electronic load sensing. The tractor could sense implement requirements and adjust hydraulic flow and pressure automatically. This made operating complex implements easier and more efficient. Fendt's obsession with operator comfort showed in the 300 series cabin design, which was among the quietest in the industry. Sound insulation and active vibration damping created a working environment that reduced operator fatigue and increased productivity. The ergonomic control layout became an industry benchmark. Number 4. Lely Lotus Tedder, Netherlands, 1986. At number 4, we have a haymaking machine that brought new thinking to forage preservation, the Lely Lotus Tedder. The Lotus, introduced by Dutch manufacturer Lely in 1986, featured a unique rotor design that spread hay more evenly and gently than anything that came before. The rotors were mounted on individual suspension systems that followed ground contours independently. This meant consistent tedding even on rough or uneven ground. But here's the clever part. The Lotus used a curved tine design that lifted and spread hay in a way that promoted faster drying. The tines were mounted at calculated angles that created an optimal spread pattern, maximizing air exposure while minimizing leaf loss. For haymakers, leaf retention was crucial. Leaves contain the highest nutrient content, and traditional tedders often shattered leaves, reducing feed quality. The Lotus reduced leaf loss by up to 30% compared to conventional tedders. The individual rotor suspension meant the machine could work at higher speeds without sacrificing quality, increasing daily capacity. Farmers could ted more acres per day, and the faster drying times reduced weather risk during haymaking. The machine also featured an automatic folding system that made transport safer and easier. The rotors folded vertically, creating a narrow transport width that was perfect for European roads and farm lanes. Number 3. Kuhn Axis Fertilizer Spreader, France, 1988. The bronze medal position goes to the Kuhn Axis, a fertilizer spreader that brought aerospace-level precision to agriculture. Released in 1988 by French manufacturer Kuhn, the Axis featured spreading disc technology that was developed using computer modeling and wind tunnel testing. Yes, you read that right. Kuhn actually used wind tunnels to optimize disc and vane design. This attention to detail resulted in spreading patterns that were remarkably consistent and accurate. The Axis introduced weighing systems that constantly monitored actual application rates and adjusted spreading parameters in real time. If the fertilizer was flowing faster or slower than expected, the system compensated automatically. This eliminated the guesswork and reduced application errors. The spreader featured border spreading functions that could reduce spreading distance on one side for working field edges. This minimized waste and reduced environmental impact in sensitive areas near waterways. The system could create asymmetric spreading patterns, which sounds simple but required sophisticated control technology. Kuhn also introduced dust suppression systems on the Axis that reduced operator exposure to fertilizer dust. The hopper design included baffles and covers that controlled airflow, keeping dust contained. This improved operator safety and working conditions significantly. The Axis demonstrated that spreading accuracy directly impacted farm profitability. Precise application meant optimal crop nutrition, reduced input costs, and better environmental stewardship. This machine helped shift industry thinking toward precision as a profit center, not just a nice-to-have feature. Number 2. JCB Fastrac, United Kingdom, 1991. Okay, technically the Fastrac arrived in 1991, just after our decade, but its development throughout the late 1980s and its revolutionary impact earned it the number 2 spot. The JCB Fastrac was genuinely ahead of its time. While everyone else was building traditional tractors, JCB asked a radical question. Why can't a tractor travel at highway speeds and still work effectively in the field? The Fastrac featured full suspension on all 4 wheels, something unheard of in tractors. This suspension allowed the Fastrac to travel at speeds up to 40 miles per hour on roads while remaining stable and comfortable. For farmers who spent hours each day traveling between fields or to market, this was revolutionary. But JCB didn't sacrifice field performance for road speed. The Fastrac featured 4-wheel drive, diff locks, and adequate ground clearance for field work. The full suspension actually improved traction in the field by keeping all wheels in contact with the ground on uneven terrain. The automotive-style cab was another innovation. Instead of the traditional tractor seating position, The Fastrac featured a central driving position with car-like controls. Visibility was exceptional in all directions. The ride quality at speed was comparable to a truck, not a tractor. The Fastrac challenged assumptions about what a tractor could be. It demonstrated that farmers didn't have to choose between field performance and transport efficiency. Today's high-speed tractors all owe a debt to JCB's innovative thinking. Number 1. Deutz-Fahr Agrostar with electronic systems, West Germany, 1987. And at number 1, the European farm machine from the 1980s that was most ahead of its time, the Deutz-Fahr Agrostar, with its revolutionary electronic management system. Introduced in 1987, the Agrostar featured the Datatronic system, one of the first comprehensive electronic tractor management systems. This wasn't just a digital display. This was an integrated computer system that monitored and controlled virtually every aspect of tractor operation. Datatronic provided real-time information on engine performance, fuel consumption, hydraulic system status, PTO operation, and implement performance. It could diagnose problems, suggest optimal operating parameters, and even predict maintenance needs. In 1987, this level of integration was science fiction. The system featured programmable functions that allowed operators to save preferred settings for different implements and tasks. Push a button and the tractor would automatically configure hydraulics, PTO speed, and other parameters for that specific job. This saved time and reduced errors. The Agrostar's electronic control extended to the transmission, which featured electronic power shift control with automatic shifting based on load conditions. The system learned operator preferences and adapted its shifting strategy accordingly. This early form of artificial intelligence in agriculture was decades ahead of widespread adoption. Deutz-Fahr also integrated implement communication, allowing compatible implements to send data to the tractor and receive control signals. This bidirectional communication laid the groundwork for modern ISO bus systems that are standard today. The Agrostar demonstrated that electronics and computing could make farming more efficient, profitable, and enjoyable. It proved that farmers would embrace technology if it delivered real value. Every modern tractor with an electronic display, programmable functions, or automated controls traces its lineage back to innovations like the Datatronic system, from intelligent combines to precision spreaders, from revolutionary transmissions to electronic management systems. These 10 machines changed agriculture forever. What's remarkable is how many of these 1980s innovations are still relevant today. Precision application, electronic control, automated adjustments, operator comfort. These weren't just buzzwords in the 1980s. European engineers were actually delivering working solutions to real farming challenges. These machines proved that innovation in agriculture didn't have to wait for the digital revolution. With clever engineering, attention to farmer needs, and willingness to challenge conventional thinking, European manufacturers created tools that genuinely improved farm productivity and profitability. The 1980s might be remembered for big hair and bigger shoulder pads. But in the fields of Europe, something far more important was happening. Engineers were building the foundation for modern agriculture, one innovative machine at a time. What's your favorite piece of farm machinery from the 1980s? Did we miss any revolutionary machines that deserve recognition? Let us know in the comments below. And if you enjoyed this journey through agricultural history, don't forget to like, subscribe, and hit that notification bell for more content on the machines that feed the world. Until next time, keep those fields fertile and those machines running.